In this video, I'd like to continue talking about using the Pythagorean identity, specifically that sine of theta squared plus cosine of theta squared is equal to 1. And we can use this identity to solve problems like this, where we are told that some angle is located in a specific quadrant, and we're told either the sine or the cosine, and we need to figure out the other trig value at that angle. Now with this problem, we are told that our angle is in quadrant 1, and we are told the cosine value. And the general idea is that we will take our cosine value here, plug it into this formula, and then solve for the sine of the angle. So to start that, we will replace this with 10 over 17, and we'll have to square that. So we get the sine of theta squared plus 10 over 17 squared is equal to 1. And we'll need to solve for the sine function since that is what we're trying to compute. So let's subtract this fraction squared, move it to the other side. We get the sine of theta squared is 1 minus this fraction, but let's actually square everything out. 10 squared is 100, and 17 squared is 289. And before we take a square root of everything, let's combine this into one fraction. We can rewrite 1 as just 289 over 289, and then in the numerator we can subtract 100 from 289 to get 189. And at this point, we can take a square root of everything so that we get the sine of theta is plus or minus the square root of 189 over 289. And remember, when you're taking a square root to cancel out a square, we need to put plus or minus to account for the fact that there are two possible solutions to this, when this is negative and when this is positive. And both of these solutions are generally valid, but only one of them will be in quadrant 1. Since we are told the cosine of our angle is a positive value, and remember when dealing with the unit circle, we have a point x comma y. This radius is 1 since it's the unit circle. And the x value is the cosine of the angle. The y value is the sine of the angle. And the x values are always positive on the right half of the coordinate plane. And what this tells us is that this could be in quadrant 1. The cosine would be positive in quadrant 1 or in quadrant 4. And this solution will tell us the sine value in either quadrant 1 or quadrant 4, but specifically we want quadrant 1. And in quadrant 1, the sine value, which is the y value, is a positive number. So in our case, we know that the sine of theta 1, it has to be a positive value since we are in the upper half of the coordinate plane. So we are dealing with the positive value. The negative value, again, will give us the sine of the angle in the fourth quadrant. So to simplify this, the sine of theta 1, forgot to put all of that in here, would be equal to the positive square root of 189 over 289. And the square root of 289, we already know, is 17, since 17 times 17 is 289. And the square root of 189, we can simplify that, but it's not a perfect square. So if we look at a tree for the square root of 189, or just this number here, it is divisible by 9 since its digits add up to 18, which is divisible by 9. And 9 times 21 gives us 189, and 21 is 7 times 3. But 9 is a perfect square, so we can simplify the square root of 189 into 9 multiplied by 21, and we can actually take a square root of 9. So this is 3 times by the square root of 21, and we can rewrite the sine of this angle as 3 root 21 divided by 17.